So here we have inverse trig questions with graphing. You've got fx, which is 2 cos inverse of x, and gx, which is sine inverse of 2x squared minus 1. And you're firstly asked to graph the first one, which shouldn't be too difficult. Graph fx. Then you want to show that g dash x equals f dash x. Then think of some sort of relationship between the two in this question. And then finally graph y equals gx. So that's basically what they're asking you to do. You've got this sort of stepwise lead through. And let's do it one by one. So first step is calculate. First step is to graph. So graph fx. Well, what is fx? Fx is your 2 cos inverse x. Now, you should be comfortable with what cos inverse x looks like. Cos inverse x is a trig inverse function that looks like this. Probably draw it a little bit better. And basically, it goes from -1 to 1 before we do any modifications. This is -1 to 1. And it's going to go from 0. And it goes to pi over 2 and pi. So that is what the graph should look like when it's cos inverse x. But of course, this question is not just cos inverse x, it's 2 cos inverse x. So you understand that's just a vertical dilation. You're just pulling it up, which means, well, nothing happens to the left and right. This is still -1, and this is still 1. But of course, these now get doubled. So that becomes 2 pi, and that becomes pi. And that therefore is the graph of y equals 2 cos inverse of x with a domain of -1 to 1 and a range of 0 to pi. So that's part 1. Quite straightforward. We now want to consider what fx is and also what gx is. And there is something that's rather subtle that we'll need to focus on here. Now, we want to show that the derivatives are this equal. So let's do f dash x first. That's quite straightforward. F dash x, you're just deriving 2 times cos inverse. So it's just 2 times -1 over the square root of 1 minus x squared. So the answer is -2 over the square root of 1 minus x squared. Done. Easy. Now we need to show g dash x is the same. So g dash x, you're firstly going to derive inverse sine, which is 1 over the square root of 1 minus bracket squared times the derivative of the bracket. This is just the chain rule, and we're just going to use this inside. Now, the derivative of 2x squared minus 1 is just going to be 4x. That's nice and easy. All over the square root of 1 minus, let's do a bit of expansion. So that's 4x power 4 minus 4x squared plus 1. Now, that's going to be the square root of 1 minus 4x power 4 plus 4x squared minus 1, which of course means the 1 and minus 1 cancel, leaving us with 4x squared minus 4x power 4. Now, let's do this step by step. So this will equal 4x all over the square root of 4x squared times 1 minus 4x squared, which means you're going to get 4x all over the square root of 4x squared times the square root of 1 minus x squared. Nice and simple. And now we have this here. If we have the square root of 4x squared, I mean, we could just go, okay, that's just 2x, right? If we think it's just 2x, then, I mean, the x's will cancel, the 4 will cancel. So you're just left with 2 over the square root of 1 minus x squared. And then, wait a minute, it doesn't match. Which means something has gone oddly wrong. And if you take a look at this, and you take a little bit while to actually look at this, there is one place where there is a mistake, which is actually a pretty common mistake. And that mistake here makes all the difference. And if you take a look, and it's actually right here. See, when you take the square root of something squared, like x, or instead of x, I'll use y. When you take the square root of y squared, it's not y. I mean, it might be, but it also might not be. And what do I mean by that? So let's just do a little bit of explanation. And that is going to be the source of the error. See, when you take the square root of a number like 25, you're only meant to take the positive answer of plus 5. Okay, it's plus 5 only. It's not negative 5. This is a very different question to, for example, if x squared equals 25, then of course the answer is x equals plus or minus 5. But the point here is actually x equals plus or minus the square root of 25, which is plus or minus positive 5. This bit here is just 5. So noting that, if I have 5 squared, that is of course 25. And if I take the square root of 5 squared, that's the square root of 25, which is 5. As expected, you got what you started with. But if I start with negative 5 squared, we all understand that's still 25. But if I take the square root of negative 5 squared, that becomes the square root of 25, which is now positive 5. Importantly, it's not negative 5. And so for that reason, the square root of y squared is not equal to y, but it will always end up being the positive version of y. So it's the absolute value of y. And that is important for us here. It's not the square root of 4x squared is 2, that's fine, because we know 2 is positive. But the square root of x squared is not x. It's the absolute value of x. The absolute value of x. Now the 4 and 2 will cancel. That's not a problem. So you get 2. You get x divided by the absolute value of x times the square root of 1 minus x squared. And when you have x divided by the absolute value of x, there are two options here. Either x is positive, so then they just cancel, or x is negative, and you'll get negative 1. And how do we know? Well, we know because they told us. This is gx, remember? And for gx, x is negative. It's between negative 1 and 0. So if x is negative, then the absolute value of x is negative x. Which of course means we then get negative 2 over the square root of 1 minus x squared. So with that in mind, having found that g dash x is negative 2 square root 1 minus x squared, we are now in a position to say that f dash x equals g dash x. For x being negative. If you look at part 2, it also says for x between negative 1 and 0, for x negative. So we've got part 1, we've got fx equals 2 cos inverse of x, and we've drawn it. Now part 2, we've now shown that g dash x equals f dash x, or x in this domain. Now, part 3 is hence or otherwise express gx in terms of fx. Well, see, because we have now got gx, g dash x equals f dash x. The gradients are equal, which now means they're always equal to each other. We can just integrate both sides with respect to x. And that really means gx is just fx, except maybe they differ by a constant. They're literally basically going to be the same graph, but maybe offset. Okay? Maybe one's above, maybe one's below by a certain amount. And we just need to find this c. As you know, how do you find c? Well, let's pick a number and sub it in. So let's sub x equals 0, for example. Okay, so if we sub x equals 0, f of 0 is 2 cos inverse of 0. Well, we already know that from our graph that that's going to be pi. Cos inverse of 0 is pi over 2, and times it by 2 is pi. G of 0 is going to be sine inverse of 2 times 0 minus 1. So this is sine inverse of -1. And the sine inverse of -1 is going to be, well, 3 pi over 2. So having picked a number, we've now got 3 pi over 2 being g of 0 must equal f of 0, which is pi plus c. So c must equal pi over 2. So basically we took this and then went g of 0 equals f of 0 plus c. We could have picked some other number within the domain. I just happened to pick 0, which is nice and easy. Other easy and possible answers probably would have been -1. Anything else other than 0 and -1 probably would not have been so easy. You can't pick 1 because there's no g of 1, according to the domain they've given you. But 0 and -1 would have been the sort of more obvious choices. And I went with 0. So we now have g of x must equal f of x plus pi over 2. There's a mistake here. Sine inverse of -1, there's a domain issue. It can't be -3 pi over 2. It can't be 3 pi over 2. It must be -pi over 2. It's -pi over 2. Because sine inverse is always between plus or minus pi over 2, which means that that should be minus pi over 2. Which then means c must equal -3 pi over 2. Which means the concept is the same, but our graph is indeed incorrect. We actually want to shift it down by 3 pi over 2. And I also neglected the domain, so which came as an afterthought. So it will be the same thing, same idea, but this should be -3 pi over 2. And noting, of course, note that the question is x is from 0 to -1. So we'll only take this branch. We'll only take this branch. And we'll shift it down by 3 pi over 2. So that means from pi, it's going to go to -pi over 2. And 2 pi is now going to become pi over 2. And you'll get something that looks like this. So this is y equals gx, which we note is fx minus 3 pi over 2 for x between 0 and -1. And that's how you did the question.